Hello, my name is Daniel Fernandez. I'm the owner of scienceinhydroponics.com, and today we are going to be doing an interesting video where we will be preparing pH buffers from scratch. Usually these solutions are used very frequently in hydroponics to calibrate our pH meters, and you can buy them commercially either in the solution form or you can buy little packets that you can use to prepare them. However, this can get quite expensive, and you can actually prepare these buffers yourself if you have adequate materials to do so and you have the raw salts that are required to do so. So I'm going to show you how this is done. So a buffer is a solution that resists changes in pH, and the buffer is always prepared using two substances. We use an acid and we use its conjugated base. In this case, we are going to be using citric acid and potassium citrate. Why, you ask? Because these substances can be bought for really cheap and at a very high purity. Why at a very high purity? Because these are used in the food industry a lot. There's a lot of food stuff that contains citric acid and also potassium citrate. So we can take advantage of this fact to get two very cheap salts and use them to prepare our buffer solutions. Also, thanks to the fact that citric acid is a triprotic acid, so it has 3 protons it can give up in solution, we can prepare buffers either at pH 4 or, well, we can prepare buffers around a big range of pH that includes pH 4 and pH 7, which are the two buffers that we need to calibrate our pH meters. So, join me in the preparation of buffers completely from scratch. Okay, so let's proceed with the preparation of the buffer. We are going to prepare the pH 4 buffer first. We are going to be preparing 250 milliliters. We need calibrated volumetric material for this preparation because it needs to be quite precise. Now, it is true that a buffer's pH does not depend as strongly on the volume as in other measurements, but in this particular case, we want to be as precise as possible because it does change as a function of the concentration. These buffers are 0.01 molar, so we want to make sure that we prepare exactly what we want. Now, the amounts that I'm gonna weigh in this scale can measure up to 1/100th of a gram, and that's the precision that you will need for this preparation. Now, the first step, as always, is to purge the glassware. So the first thing that I'm gonna do is that I'm gonna purge this volumetric flask, hopefully without destroying my scale in the process. So I'm going to purge . Three times. I have my purged volumetric flask, which I'm gonna keep here. And now I am going to do the same thing with my beaker. So just purging with this distilled water. You do need distilled water for this preparation. You don't want to use other sources of water like tap water or RO water. You want to use specifically distilled. If you can get the old distilled, better, but distilled is good enough. So now, in order to avoid movements in the weight, I'm gonna dry this with a clean towel. Now that we have a clean beaker, I'm gonna place it here. I'm gonna tare it. The weights that you need to so the amounts you need to weigh need to be exactly the amounts that are in the description for the pH 4 and the pH 7 buffers. So first I'm gonna weigh the potassium citrate, which I'm going to weigh 2.63 grams of it. And I want to be as exact as possible. So I want to do this as exactly as I can within the precision offered to me by this scale. The scale was previously calibrated, so that's something that I would advise you do if you want to do this. Although the most important thing for the pH of the buffer is the ratio between the two salts. So provided that you weigh both as exactly as possible, it should be fine. Got past a little bit. And that's 2.63, which is exactly the amount that we want to weigh. So now, after you do this, you are going to take this and you are going to add some distilled water to it. Exact amount is not important. We're just going to dissolve this and then we are going to transfer it to our volumetric flask. I'm using class A volumetric material, so I am having as much precision as I can with this. Generally, you will need potassium citrate and citric acid are very soluble, so you won't need much water to fully dissolve these amounts. Now I am going to remove the stopper and I am going to transfer this into the volumetric flask. Now it is very important to make sure you wash the flask with distilled water so that you quantitatively transfer everything that remains. So just usually takes around 50 to 100 mils to transfer everything, but that's fine. So now we have prepared the first part. So I'm going to put the stopper here in the meantime. And now I'm going to do the second part. So now we're going to purge again. So 1, 2, 3, and now you get a clean towel. I'm gonna clean this. One of the reasons why cleaning this and drying it is important is also that when you weigh, you might need to take out salt, as you saw me do, and if this were wet, then it would be impossible. So if this is wet, we would need to weigh very precisely on our first try, which is unlikely. Okay. Now I'm gonna tear this again. And now the amount of citric acid that I'm gonna weigh. Also need to clean the spoon. Is going to be 3.45 grams of citric acid. 3.45. So I got a little bit past it, so I'm gonna remove. Okay, so this is within the precision of the instrument, so I'm gonna just add this 3.44. Not worth it to try to get it into like the just 0.01 grams. So I'm gonna take this, let's make sure this is closed, get it out of our field of view. Now this is the citric acid. So I'm going to do the same thing I did last time. I'm going to add some water so that I can dissolve it. And in the same, it's the same thing as with the potassium citrate. This is very soluble, so you will see this dissolve fairly quickly. It is not necessary to heat this or anything. It should dissolve within just a couple of minutes at most, just with stirring by hand. I'm using a 250 milliliter beaker because it's the easiest for a 250 milliliter volumetric flask, but you might want to use a larger beaker if you're going to prepare larger amounts. Okay, now I'm going to remove the stopper, and since this is dissolved, I'm going to execute the transfer. Same as before, we want to ensure everything is transferred. So you want to get everything. Just make sure you wash that pretty thoroughly, so that you get anything that might have gotten into the walls when you were stirring with your distilled water. Okay. Now we ensure these things are mixed, and now we just need to take these to final volume, which I'm going to just remove the cap from my flask. And take it almost all the way. And now I'm just gonna use the and we continue slowly. You can watch some of my other videos preparing solutions to see how this looks, because you want to reach the point where the meniscus is just above the line that's on the glassware. And that's it. And now we just turn it 3 times. Don't shake it. Don't be a savage. Just shift it like this. And there we go. This is a pH 4 buffer that has been prepared using calculated amounts of citric acid and potassium citrate. If you're interested in knowing how these calculations were done, then leave a comment and I might make a video about that. Now, the Achilles heel of this buffer solution is that the citrate and citric acid buffer is food for microorganisms, because citrate is a carbon source that fungi love. So these will spoil pretty quickly. So in order to solve this issue, I recommend you get 2 ice trays. These are like silicone trays. And I got 2 colors because pH 4 buffers are usually colored, they're dyed usually pink, and pH 7 buffers are usually dyed green. So what I'm going to do is that I'm gonna put all my solution, or as much of the solution as I can, within this tray, and then I'm gonna freeze these, and then when I want to do a reading, I can just take one of these cubes out and let it thaw. Do not heat it, just let it thaw, and then you can use that to calibrate your electrodes. The same goes for the pH 7 buffer. So now I am going to just, first of all, remember, we are going to purge using the buffer. Because the buffer is what we want to add, so we will just purge with a little bit of the buffer to ensure that we wash any impurities or any stuff that might be there. Although these have already been washed, but just to be sure. Always purge 3 times. Never hurts to purge more. Wonder if it's gonna be enough. Probably not to fill the entire thing. Just try to get all these droplets into the trays as well as you can. And there you go. Now you put this into the freezer and you can enjoy your buffer without it spoiling as a function of time. If you're not gonna do this and you just keep this buffer in normal conditions, it will spoil pretty quickly. Probably won't last more than a week. So make sure that you either freeze it or just make as much as you need for that day and then don't make a lot more. But this freezing solution should be pretty good. We'll see another video where I will use this and show you how I actually perform the calibration buffer process with this buffer solution. Okay guys, so we just saw how I prepared the pH 4 buffer solution, and now we are going to prepare the pH 7 buffer, but we're just gonna speed through the process because you just already saw how it's done. So I'm just gonna show you from this perspective so that you can get a better look. And it is, for this buffer, it is 7.14 grams of the potassium citrate and 0.35 grams of the citric acid. You can find these values in the description below. Okay, so let's go. There you go. We have now prepared pH 4 and pH 7 buffers and put them in silicone trays so that we can freeze them so that they don't spoil and we can use them later. So on a future video we'll see how we can actually use these buffers to calibrate a pH meter. It should be fairly the same way you do it with the regular commercial solutions, only that you would need to thaw them and wait for them to reach room temperature. Thank you very much again for watching this video. Please remember to like and subscribe and share. Sharing is very important. Nobody's sharing. Please share my videos. If you enjoyed this video, you have any topic suggestions, feel free to leave them in the comments. We will probably be preparing conductivity solutions as well, so that you can use them to calibrate your EC meters in hydro as well. Thank you very much again for watching. I'll see you in the next video, and bye bye.